morning, students. Chapter 7, System of Particles and Rotational Motion. Today we will see some questions based on center of mass. Okay, how to find center of mass of given system of particles or for given body. First question, example 7.1. You are given one equilateral triangle having side 0.5 meter. On each corner of equilateral triangle, some particles are placed having mass 100 gram, 150 gram and 200 gram. You have to find where is center of mass of the system. See, first of all, we have to find center of mass with respect to something. Yes, here I will find center of mass with respect to this 100 gram particle. So yes, first of all, I will take this 100 gram particle at origin. So yes, it becomes x-axis and yes, it becomes y-axis. Okay, so first of all, take origin at this 100 gram, or we can say that it is first particle, it is second particle and it is third particle. Okay, so yes, first of all I have to write take origin at first particle having mass 100 gram, Clear? So yes, we have to find center of mass with respect to this point, means this origin. Okay, so yes, as you are given three particles and they are in two dimensional, so yes, we have to use this equation. Our center of mass is equal to m1r1 plus m2r2 plus m3r3 upon m1 plus m2 plus m3. Yes or no? Yes, we have to use this equation. Okay, so first of all, we have to find masses of three particles and their positions vector. Yes or no? So yes, see, first of all, length. Here it is. It is first particle, second particle and third particle. What is mass of first particle? m1. It is 100 gram. Mass of second particle, m2. It is 150 gram. Mass of third particle, m3. It is 200 gram. Simple? Yes, it is simple. So yes, we have m1, m2 and m3. Now as we have to find center of mass with respect to origin, we have to find position vector of first particle, second particle and third particle with respect to origin. Then how to find? See, position vectors of three particles with respect to O. See, position vector of first particle, this one. It is at origin. So yes, its position vector is 0, 0. Simple. Yes or no? Yes, its position vector is 0, 0 because it is at origin. So what is distance from origin? It is 0, 0. Simple. What is position vector of second particle? R2. What is position vector of second particle? R2. R2 is equal to, see, second particle is here. Here means it is on x-axis. Second particle is on x-axis. So its y component is 0. And yes, see, from origin it is at 0.5 meter. So what is R2? It is 0.50 meter. Simple? Hello? Yes or no? Yes, please. Now, third particle, it is here. Here it is third particle. So how to write R3? See how to write R3. Yes, we cannot write this R3, that is position vector of third particle, directly. Okay, why? Because see, if one particle is on x-axis, we can directly write like this. If one particle is on y-axis, then we can directly write it. But it is making some angle with x-axis. And see, from figure it is clear. It makes angle 60 degree. With x-axis. Yes or no? Yes. Yes or no? Yes. Okay. So yes, what is its position? How to find its position? How to find its position? See, it is called its x component and it is called its y component. Yes or no? It is third particle. Simple. So it is its x component and it is its y component. Now how to find x component and y component? We know that if it is its magnitude 0.5 and it makes angle 60, 0.5 makes angle 60, then how to write this? I can write this 0.5 cos 60, 0.5 sin 60. Simple. Yes or no? Yes, you know this topic. Okay. If it is one vector having magnitude 0.5 and it makes angle 60, then it has two components. If it is A, then it has two components. It is A cos theta and here it is A sin theta. Yes or no? Yes. So similarly, 0.5 cos 60, 0.5 sin 60. Okay. So yes is equal to, R3 is equal to 0.5 cos 60. Yes, cos 60 is, yes, cos 60 is, it is 1 by 2. It is 1 by 2. 0.5 sin 60. Yes, sin 60 it is root 3 by 2. It is root 3 by 2. Okay. So 0.5 divided by 2 means it is 0.25 and here it is 0.25 root 3. Here it is 0.25 root 3 meter. So yes, first of all, you have to find, yes, three masses they are given simply. Okay, M1, M2, M3. You have to find R1, R2 and R3. R1, R2 and R3. Simple. Now you have equation. Which equation? Yes. Okay, now position vector. Now position vector of center of mass. That is R center of mass is equal. That is R center of mass is equal to M1 R1 plus M2 R2 plus M3 R3 divided by, it is M1 plus M2 plus M3. Simple. Okay. Is equal to, is equal to M1 it is 100. What is R1? 0, 0. M2 it is 150. What is M2? It is 150. What is R2? R2 it is 0.50. It is 0.50. Okay. Then M3. What is M3? It is 200. And what is R3? It is 0.25. And here it is 0.25. Okay. Divided by M1 100, M2 150. And M3 it is 200 and M3 it is 200. Clear about this? Okay. Is equal to. Now what you have to do? See, here it is. This 100 you have to multiply inside. Very simple. Okay. How to calculate this? First of all, this 100 you have to multiply with these two components. So it will be 0, 0 simply. Then this 150 you have to multiply with this both. It is 150 into 0.5. 0.5 means it is 5 divided by 10. 0.5 means it is 5 divided by 10. So yes, 150 into 5 divided by 10. 0 cut 0 cut 15 into 5. Yes, it is 75. Simple. Yes or no? Okay. So it is 75. 150 into 0, it will be 0 simply. Okay, then here it will be plus. Here it is plus. Now again, you have to multiply this 200 with 0.25. You have to multiply this 200 with 0.25. So yes, 200 into 0.25. 25 means 0.25 means 25 divided by 100. This 2 0 cut, this 2 0 cut. So 25 into it is 50. So yes, it is 50. And here 200 into 0.25 root 3 means it is 50 root 3. It is 50 root 3. Simple. So yes, divided by, here it is divided by 100 plus 200, 300. 400, it is 450. Okay. So yes, I think it is easy how to calculate this. Okay. Now, x component, y component. component, x component, y component, x component and y component. Then how to write next step? See, is equal to this. First of all, you have to add x component, that is 0 plus 75 plus 50. Then y component 0 plus 0 plus 50 upon root 3 and divided by, yes, and divided by it is 450 and divided by it is 450. Simple? Yes or no? Yes, it is. It is simple. Divided by it is 450. So yes, it is 0 plus 75 plus 50, 0 plus 0 plus 50, root 3 divided by 450. Now 75 plus 50, it is 125. So yes, here I will write R center of mass is equal to, okay, here I will write R center of mass is equal to, it is 75 plus 50 is 125 and yes, it is 50 root 3 only, it is 50 root 3 divided by it is 450 divided by it is 450. So yes, R center of mass is equal to 125 divided by 450 and here it is 50 root 3 divided by 450 meter. You can further divide this too. Okay, 125 divided by 450, 50 root 3 divided by 450. Whatever you will get, it is your answer. Whatever you will get, it is your answer. Clear? Yes, it is right. Now further you can simplify this. Okay, clear? So it is how to calculate this question. It is how to calculate this question. If you are given system of particles, then how to find its center of mass? See, this calculation is easy. Okay. See, this calculation is easy. Okay. First of all, you have to multiply this inside. Okay. Then you have to add x component and y component symbol. Okay. So yes, this is one question which is based on center of mass of system of particles. Now we will see next question. See what is next question? Find center of mass of uniform L-shaped lamina as shown in figure. The mass of lamina is 3 kg. Yes, you are given one L-shaped lamina and you have to find its center of mass. See, the mass of the lamina is 3 kg. The mass of lamina is 3 kg. Okay. Yes, what I will do, see, you are given some dimensions. It is 0, 0, it is 2, 0, it is 1, 1, and it is 0, 2. Okay, and this height is 2 meter. You have to find its center of mass. You have to find its center of mass. See, as it is L-shaped lamina, I can divide this lamina in 3 parts. I can divide this lamina in 3 parts. First, second, and third. Okay. I can divide this lamina in 3 parts. That is first, second and third. And see, these 3 parts are identical. Obviously these 3 parts are identical. So if mass of lamina is 3 kg, what is mass of this first part? 1 kg. What is mass of this second part? 1 kg. What is mass of this third part? 1 kg. Okay, so yes, let lamina is divided. Let lamina is divided in 3 equal parts. Let lamina is divided in 3 equal parts. Let lamina is divided in 3 equal parts. So therefore, mass of each part, that is M1 is equal to M2 is equal to M3 is 1 kg. Simple? Yes. M1, M2, M3 is equal to, it is 1 kg. Now, see, we know that if I have one square plate like this, then its center of mass lies at its center. Yes or no? Its center of mass lies at its center. So I can consider the whole mass of this square plate lies at its center of mass. So now what I will do? See here carefully. Here it is. For first plate, it is its center of mass. Yes or no? For first part, it is its center of mass. Okay, let we draw perpendiculars on x and y axis. We draw perpendicular on x and y axis. This total distance is 2. So obviously this distance is 1. So obviously this distance will be 0.5. And this distance, it is also 0.5. Simple. Again, I am taking first part. Its center of mass is here. Yes or no? Yes. From this origin, what is distance of this x component? It is 0.5. What is distance of y component? It is 0.5. Okay. So yes, position vector with respect to origin. Okay. Position vectors of parts with respect to origin. First of all, R1. See, again, here it is its center of mass. If I draw perpendicular on x-axis and I draw perpendicular on y-axis, this distance is 0.5, this distance is 0.5. So it is 0.5 meter. Simple? Yes, it is simple. Okay, then R2 means the second part. For this second part, where is its center of mass? Here, at this point. So simple, you have to draw perpendiculars on x-axis and then you have to draw perpendicular on y-axis. So see, for this second part, for its center of mass, x component is, this total distance is 1 and it is 0.5. This total distance is 1 and it is 0.5. So it is obviously 1.5. But what is y component? Yes, y component is 0.5. Y component is, it is 0.5. Simple. Okay. Now for third particle, that is R3. Where is its center? Here it is. So obviously from this point, draw perpendicular on x-axis, and draw perpendicular on y-axis. So see, for this third part, x component is 0.5, y component is 1.5. So it is 0.5 and here it is 1.5. Simple. So yes, we have three masses m1, m2, m3. We have three position vectors r1, r2 and r3. Clear? Why we have to consider their center? Because for square plate, the total mass is concentrated at their center. That's why we are taking their center. Okay. So yes, position vector of parts with respect to origin r1, r2 and r3 that you are given. Okay. Now. Yes, we have to use equation that is let position vector of center of mass is r center of mass. Then r center of mass is equal to m1r1 plus m2r2 plus m3r3 divided by, it is m1 plus m2 plus m3. Okay. Now we have to put data, that is r center of mass is equal to m1, it is 1. What is r1? 0.5 plus 1. What is r2? It is 1.5, 0.5. Then it is plus 1, it is 0.5, 1.5. And here it is divided by 1 plus 1 plus 1. Simple? Yes, it is simple. So see, here it is 1 into 0.5 will be same. 1 into this will be same. It will be same. So yes, we have to add all x component. So all x component, how to add? You can also add from this 0.5 plus 1.5 plus 0.5. So it is 0.5 plus 0.5 is 1 and it is 2.5. Then it is 2.5. Similarly, it is 0.5 plus 0.5. So it is 1. So it is 2.5. It is 2.5 and here it is divided by 3. So it is 2.5 divided by 3. It is 2.5 divided by meter. Yes, it is meter. Clear? Okay. So yes, it is position vector of center of mass for this given system. How to find? Simple. So yes, there are two questions. How to find center of mass for given system. Now next question from exercise 7.2. In the HCl molecule, separation between nuclei of the two atoms is about 1.27 angstrom. Find the approximate location of center of mass of the molecule given that chlorine atom is about 35.5 times as massive as hydrogen atom. Yes. See, what is given actually? In the HCl molecule, the separation between nuclei of the two atoms is about 1.27 angstrom. Suppose, yes, if I want to draw, I can draw like this. H, and it is Cl. Yes, it is H plus and Cl minus. I know, okay. So yes, separation between them is 1.27 angstrom. Clear? Find the approximate location of the center of mass of the molecule given that chlorine atom is about 35.5 times as massive as a hydrogen atom. Yes, what is meaning of this? See, first of all, a center of mass you have to find with respect to some reference point. Yes or no? Here you have to find center of mass, but with respect to which atom? So yes, we will assume. Okay, we have to find center of mass with respect to hydrogen. Okay, and for that we will put this hydrogen on origin. We will put this hydrogen on origin. So obviously it will become x-axis. Okay, or to find center of mass with respect to hydrogen atom. Okay, so therefore put H atom on origin. Simple. So yes, we have to find center of mass with respect to H atom. So put H atom on origin. So yes, we have two particles. Yes, we have two particles, one H and one Cl. Okay, so yes, how to find their mass? Yes, I am assuming that M1 is equal to M H. Or suppose it is M, okay, mass of this hydrogen atom, it is MH. You know it is MH. Okay, so what is mass of chlorine? M2. Mass of chlorine is equal to, how to write? See, given that chlorine atom is about 35.5 times as massive as hydrogen, so I can write it as 35.5 times mass of hydrogen. Simple. Hello? Yes or no? Yes it is. Yes it is. Okay. So M1 is equal to it is MH and M2 is equal to MCl is equal to this 35.5. Now what about X1 and X2? X1. Why X1 and X2? Because they are in one dimension. Yes. So what about X1 and X2? X1 means position of this first, that is H atom from origin. Now it is placed at origin, so its distance is 0 obviously. And X2 is equal to it is distance between them, that is 1.27 angstrom. That is 1.27 angstrom. Okay, so now yes, you have to put equation that what is center of mass of system with respect to H. The center of mass of molecule with respect to H atom. X center of mass is equal to M1 X1 plus M2 X2 upon M1 plus M2. So X center of mass is equal to M1 means it is MH, X1 means it is 0, plus M2 means it is MCl means it is 35.5 MH, and here it is 1.27 angstrom divided by, yes, your answer will be in angstrom, don't worry. Okay, if you are taking this distance in angstrom, then your answer will be in angstrom, so don't worry about that. Okay, now M1 plus M2, M1 means it is MH plus here it is 35.5 MH. Okay, so this term will become 0. Yes, this term will become 0. So it is 35.5 into 1.27 into MH divided by, here it is 35.5 plus 1 means it is 36.5 mH. So see this mh cancels out. So 35.5 into 1.27 is equal to 36.5 divided by 36. What is your answer in angstrom? That you have to find. What is your answer in angstrom? That you have to find. And yes, you also have to write. Okay, this center of mass is near to which atom? This center of mass is near to which atom? Near to hydrogen atom or near to chlorine atom? That you have to write compulsory in comment box. Clear? So yes, answer of this question, that is X center of mass, what is its value, and center of mass is near to which atom? That you have to write in comment box. For today, these 3 examples are enough. This is it.